UNC. This was the mid-capstone, and I want to, even before I started, I want to apologize for it. The way these things go is that the time that you have, and you always underestimate the amount of the problem that you are proposing and what you can deliver within the 1 month period or so, the time that we had.
Sanjay, can I hang with you?
Yes.
Can you give a short introduction about yourself?
About me. I am Sanjay Mishra. I am finishing up my PhD in my day job at the Vanderbilt, and up here I'm in the first cohort of the data science at the National Software School. So at the outset, what I had set out was rather too ambitious, and that was that as the times are changing and as the climate is warming, there is a likelihood and there is an established, some kind of evidence that some of the diseases that are carried by the vectors, which in biology mean basically the bugs that carry the diseases, it's much more comfortable for them to live in. Now you can think about tropical climates, warmer places, a lot of rain, bugs, mosquitoes, and other things, they live there far more happily than they would live in, say, colder climates like North America and Northern Europe. But as the temperatures are changing, as they've been warming up, and as the more and more rains, or the episodes of rain are becoming far more massive at some time and not so massive at the other time, you will think that generally that will make the bugs to be more conducive. And as it happens, bugs also carry a lot of diseases. For example, mosquitoes and flies, they are known to carry a lot of diseases. So it would beg to a question that yes, there is a likelihood that as the temperatures are changing, as the climates are changing, those diseases will happen far more often. Now, as it turns out that within 1 month of period that we had, I could not finish the idea that, okay, I have a data that I can use a predictor, and I have a data which I can see and then can model that in the regions where the temperatures and rains are becoming far more frequent, certain diseases will happen more often or not. But having said that, we can still utilize these tools to at least have an exploratory evidence that yes, some of the things that we are proposing, they do make sense. So I focused on this disease called Lyme. Lyme was generally considered an unknown disease in most parts of North America. Not so much it never happened, but it was considered not happening because there were far fewer known instances of that. Now, if you look at the climate change, if you look at the parameters of the climate, so this is a Shiny app. Those of you who are not familiar with it, the way it works is that you have a data set which has been processed in R, the data runs under the server, and then as you can interact with the data, and you will see a lot more of the people who follow me, they have far more interactive presentations. But as you can see here, in this, you can change the indicator, you can choose the indicator, and as you will see, some of these graphs will change accordingly. And these are not static graphs, but they are being processed in the real time, and they are changing accordingly. So if you look at, say, heating days, what heating days is that, or what you see from all of these plots is that as the time has gone by, since starting these data is from somewhere in the 1880 up to 2016, 2015, as you see in all of these trends, those where you will see them going upward, they are going upward other than certain plateaued off values. So as you see here, the surface temperature has gone up. If you look at the heating days, which is how much it takes to heat your house, that has gone up. And similarly, when you look at how much it takes to cool down your house, that has gone up, that has gone down, which means that overall the cities and our living spaces are getting warmer. Now, when you look at the incidence of Lyme, these are the known counts in the different parts of the country. As you see them, the nationwide Lyme instance is also, so this data is only from 1995. From 95 to now, as you see, the numbers have gone up, although there is some kind of a plateau here. But this data, as it accumulates far more, we will see the trend will continue to going forward. Here, you can interact with this data, and you can see the number of, if you look at the year, so this data is from 2006, these are heat maps, color-coded. Darker red means that there are more instances recorded in that part. As you go further up, and you will see that the color is getting far more darker, and these numbers of the Lyme instances, they have been going up in the Northeast. Now, if you look at a lot of these are chloroplet maps, and they tend to take a lot of time. So let's hope that it loads. Okay. Well, if it doesn't, I can, in the meantime, while it is, I can get the static. This is how the static should have looked. For some reason. So this is how, we'll come back to it and we will see that. I'll hope that it will load, but this is what it is. So if you look at from 2000, in this Northeast, you had far fewer instances at the county level. Whereas now in the 2016, you can see that most of the Northeast has become a lot of the darker red hot spots. Accordingly, if you look at the rate of temperature change, this is from 1901 to 2015, the white colors are the normals, which is where the temperature hasn't changed much. The blues where the temperature has gone towards the colder somewhat, and the reds where the temperature has gone up. And as you see here, most parts of the country, the Northeast and the West, has become redder. Whereas there are pockets where the temperature has either stayed where it is or it has gotten colder. If you look at accordingly what is happening on the rain side, the areas which are redder, they have also gotten far more wetter, which means that the regions where the temperature is going up, those are the places where the rain is now exceeding what the normals were over the centuries. Now what does it mean? Think about the diseases like Lyme, which are carried by these little, here. So these are the little ticks that are carried by the deers. And what happens is that as the temperature gets warmer, they show up usually it's a disease of the summers. And why? Because that's when the conditions are right for these ticks to be hatching out, and then they go to these molted stage. And you can see the cycle. So it's somewhere in the spring, summer season is that these larvae grow, and they're really small. As you are out, they stick onto your body, and then they transfer this bacteria, which then eventually cause the disease. And Lyme is a multifactorial disease. It affects to a lot of conditions. And it's very difficult to detect. Up till now, there's not many medicinal interventions available, which means that if we have a situation where these ticks and their spreading is more favorable for the environment, or if they have a favorable condition where the molting would not happen, that means they can survive for far too longer, the likelihood is that the humans and these disease causing vectors will have a higher likelihood of interacting with each other, and that probably could be the one that is causing these higher incidences. So now let's go back and see if the graph ever loaded. Okay, the maps did load. So basically, they just show up what I was showing, that you have these nationwide climate, this is the rate of temperature change, these are the precipitation changes, and the county map is also loaded. So now you can actually drag it, and you can see, of course it takes a little while again, but you can see. And so this is a very good visualization tool whereby you can have a lot of data, and if you're presenting it to an audience who wants to interact it at their own free time, you can have the data, and it's a very good way to present an interactive feature. This was done into a Shiny app, which, like I said, runs under R. Any questions? Yes?
In this Shiny app, behind it, like when you're loading,
Mm-hmm.
does it have all the data inside or just some kind of R?
You could do both way. You could do both way. In my case, because the data sets were so big and I wanted to deploy it, I created all the data into a single data file, and I upload it as a single data file, which is probably a better way to do it. So you would like to have data, most of the data processed at some end, and then you can upload it in your server as a single R data file. But if you have smaller data sets, you can intersect them at the server. The server will be the one which will handle all the thing, and then will present it to the web interface, whichever web interface you have. Yeah. Any more questions?
So what does that input file look like? Is it just something flat in the CSV, or
Which one?
the file that you're basically storing all this information on? I mean, like you said, you put it in
So this is the simple RStudio data file you wouldn't be able to see, but it was a CSV file. These are the multiple CSV file put together as a single data file, all in one, and then I uploaded all of them into server in one go. Yes. The data, actually, it's written. Some of the data is from CDC. The temperature data is from National Oceanic Survey. So there are multiple data sources. The incidences came from the CDC, which is the county level data. The county map itself, that is a different file that the Census Bureau maintains. They define the census, the county boundaries. So the boundaries, what is called the shape file, they came from the census. The incidences are from the CDC, and the rest of the climate data is from Oceanic Survey. Any more questions? Thank you.
Thank you.